Hello, everyone. Thank you for joining us today. My name is Mike Byrne. I'm Senior Editor with Professional Builder. I'm happy to welcome you to Professional Builder's webinar, Is All the Good Land Gone? Today's webinar is sponsored by E1 Sewer Systems. Our webinar features land development experts and engineers that will provide real-life case studies about challenging development projects and how all-terrain sewer provides for maximum density within an environmentally sensitive and economically sensible context. Discover how you can unlock and invent new land. Learn how you can develop new land in an environmentally sensitive way with maximum economic benefit for you and your community. Our speakers today are Joe Tortorello and Steve Sletner. Joe Tortorello, our first speaker, is from Signa Services. Joe is a licensed engineer with more than 30 years of experience in the wastewater pump industry. He is also a licensed California general and electrical contractor. In partnership with his son Joseph, he owned and operated Signa Mechanical for 8 years, designing, recommending, selling, and servicing the wastewater industry in California, Nevada, and Arizona. Our second speaker is Steve Sletner, Land Development Business Manager for SEH Incorporated. Steve is a professional engineer and business leader with more than 30 years of experience in project development, management, and execution. Steve has been responsible for multi-year double-digit growth of companies in commercial, industrial, and multi-use real estate development. He is adept in collaborating with multiple stakeholders, including owners, investors, and regulators to implement complex projects. Before we get started, I'd like to encourage everyone in the audience to ask questions during the course of the webinar. You can do so by using the dialog box on your viewing console. We will have time at the end of the program for Q&A. Also available in the resource tab for downloading is a brochure and a PDF of this presentation. So without further delay, I'll turn the mic over to Joe. Joe, go right ahead.
Thank you, Mike. Hello, everyone. Thank you for your time today. This is Joe Tortorello, and I'm also currently an E1 distributor for the states of California, Nevada, and Arizona, and we have 3 physical locations. Over the next 15 minutes or so, I'd like to share a case study with you regarding a property that we worked on with a home builder developer and an engineering firm towards providing a sewer system for 28 homes in a very small space in the city of Costa Mesa, California. As an overview, what I hope to show is in the case study where the goal was to maximize the number of residences that could go into a small space, thus increasing the profitability of the development. To accomplish this required creativity in many areas. My concentration obviously was on the sewer system, and also discuss why a conventional lift station would have not served in the developer's best interest, and hence a low-pressure sewer system was the best choice for this particular development. The property, which is located on Victoria Street in Costa Mesa, was a commercial professional building inhabited by a company called Viva Life Sciences. That's a picture of the building on the screen. It's a relatively small property, and like many other properties in many urban towns, would see a higher best use as a residential property rather than commercial professional property. Land is at a premium value in the town of Costa Mesa, and putting homes here would ultimately be more profitable than renting the existing building or using the land for another commercial purpose. This is a plan view of it. It's an odd-shaped property. The slide's shown in normal fashion. North is up, south is down, east and west. Property was such that to get to the sewer connection would be an uphill transition. The property sloped such that the back of the property is about 7 foot higher than the site itself. It actually required the builder to put a wall on the high end of the property due to the height difference. The intention here was to try to get 28 homes on this property, and each of the homes were in the $900,000 to $1 million range. The use of a traditional lift station would have caused the loss of as many as 2 of the residential buildings in the southeast corner of the property where the traditional lift station would have been built. This is just to give you an idea on the property itself. The frontage on Victoria Street is about 285 feet long. The width of the property is 236 feet. The long side of the property is 383 feet. The short side is 238 feet. The property covers 2.04 acres or 88,608 square feet. And the object is to put 28 houses in that piece of property. There were quite a few obstacles that the builder had to overcome. The property is zoned AP, so it would not allow for him to build on it now. It's a major hurdle that would require rezoning the area to a multifamily residential high density, which is an R2 HD category. And within that category, fell even more obstacles. For example, if it was rezoned, they're only allowed to put 14.5 dwellings units per acre on it. They had an open space requirement that said any property has to have 40% in open space, which would amount to about 35,000 square foot in this case. They had setback requirements. Rear setback was limited to 20 feet. The builder's design would have been less than that for the second story. The front setback was 20 feet. Again, he would have been less than that. And they had a restriction on the building height of 27 feet, and they only allowed 2 stories on the property. The developer, what he wanted is he wanted it rezoned to R2 HD, multifamily high density, which would allow a build out maximum of 14.5 units per acre, or 29. He settled into requesting rezoning with 28 units. But to get that, he couldn't lose any additional land, and considering the open space requirement of 40%, traditional lift station would severely impact their ability to do this. This caused them to look for alternatives to traditional lift stations. They also wanted to build a 3-story residence with a usable deck and a total height of 37 feet. Remember, only 2 stories and 27 height maximum was currently permissible, so they need to get a waiver on that. Lastly, they wanted setbacks on the rear of the residence to be 10 foot for the second floor and 3rd story, and front setback was going to be 14. This next slide will show you a artist rendering of the residences to be built. You can clearly see the density in some of the issues that I just spoke about. Pretty tight location. Potential problems for a traditional lift station would be land usage, major in this case. It would require a relatively large plot of land taken away from the land that could be used for additional residences. As I said, it was estimated that 2 lots would be lost in this community, which would amount to about close to $2 million. Aesthetics. Not only is land required, but creating an aesthetic and pleasing facility with a lift station could be challenging, requiring a building or a wall to camouflage the equipment from the community. Odor. Traditional lift station in a high-density community such as this causes great control for odor issues, not only within the community, but to the surrounding residences as well. Large, heavy equipment, pumps that are used in a traditional lift station are generally several hundred pounds and will require that a mechanism such as a crane be installed in order to be able to maintain the equipment. Electrical service, separate source would be needed other than the residence to power any pumps in the lift station. Probably would have to have the HOA fund the electrical service and collect from homeowners. Potential for power loss. If power is lost, all residents of the community are affected, so it generally requires that an emergency source of power be provided to run the pumps in the event of a power outage. Sometimes, in addition to that, or in lieu of that, they'll require additional storage capacity for emergencies on site, so residents aren't left without sewer capability. Air release valves. In this particular case, it wasn't an issue, but in many systems, which with large and quick increases in elevation, it requires a number of air release valves in the system to belch the air out so the pump doesn't get airlocked and malfunction. These would have to be located on the property. As I said, in this case, that wasn't an issue. Our rise was only about 7 feet. Regular maintenance. Traditional lift stations need to be monitored on a regular basis, so personnel are required to facilitate work at the station. Preventative maintenance is a requirement. Typically on float systems, it periodically has to be hosed off. Chemicals might have to be added, and then any maintenance, both preventative and regular, has to be done by someone. Costly. All the above adds to the potential costs of both building, operating, and maintaining a traditional lift station. Costs are often upwards of $250,000 to $500,000 for a traditional lift station. So, choice of source system. Seeing how this was developing and the desire to maximize the number of residential lots, the engineer explored the use of a low-pressure sewer system. We've worked with him before. He was familiar with our work from previous projects and collaborated with us and had discussions with us about how to do it. Also, the city of Costa Mesa had not used low-pressure sewer systems previously, and we had several meetings and presentations to the city engineer so he can gain some comfort with the system. Since it's been approved in the town, he's authorized us on several other projects in the city that were approved and used low-pressure systems. Results. Through lots of meetings, environmental reports, back and forth letters to the planning board, negotiating, some give and take, the developer achieved the important things he needed to make the project move forward, including approval of the use of a low-pressure sewer system. So he was able to get the property rezoned as R2HD. He got approval for 28 units in there. His open space requirements came out to 34.9, but they used open decks, which pushed them as open space, decks on the third floor, and that pushed them over 40%. They allowed the 3 stories and the 37 foot of height, and they gave him the setback requirements, and he got the low-pressure sewer system approved. Benefits of the low-pressure sewer: he saved on land usage. He didn't have to provide electric power separately for that. All electric power is by the homeowners. He was able to use a small diameter piping system with savings, cost savings in the street and the time also to install. And also the cost can be back-end loaded. In this case, he put the infrastructure in place in the street and hydro-tested it, but the sewer systems themselves did not have to be purchased or installed until individual residences were sold. Lastly, on the E1 low-pressure sewer system, no preventative maintenance is needed on the system, and any real-time maintenance is isolated to individual residences, so it doesn't affect the entire community as a conventional lift station would. This is a plan of the community just to show you the 28 houses, 8 houses, and we do a preliminary hydraulic analysis for any engineer that's looking at trying to do a system like this. If he provides a topo plan to us, we'll mark it up, we'll show the zones for it and figure how many units sewers go into each, how many individual E1 units would go in each zone. We end up giving him this map back. You could see the manhole where we had to connect to is in the bottom left-hand corner of this. And as I said, it's about 7 foot higher than the property. What we also gave them as part of the hydraulic analysis is a pipe sizing report. It gives you the velocities, the heads, all the pipe diameter sizes in here. And there's a secondary report, which is retention time in the pipes, how long the fluid's going to remain in the pipes for each zone in the community. Just briefly, if you're not familiar with how a low-pressure sewer system works, it takes a standard 4-inch pipe from the house for the inlet to the station. It goes through and gets ground up, goes through a progressive cavity pump, and out a 1 1/4-inch discharge line through what we call a lateral kit, which is a combination check valve and shutoff valve with a curb box going to the surface to be able to operate the shutoff valve. The control panel is generally mounted on the building wall of the residence, on one of the walls, and that's the way it would look. So here's the start of construction, what the site looked like. You can see the area of dirt, and you can also see the community around it, how tight all the housing is in this area. You can see little cars crawling along the street there, but this is the community where all this is going to go in. This is a picture of the finished community, again showing it's very close to what the artist's rendition was on it. The largest size pipes we had to use in here were 2-inch and 3-inch high-density polyethylene SDR 11 pipes for all, in addition to the laterals from each house being 1 1/4 inch. This shows the stores. We actually, since we're generals, and this was in our hometown actually, we actually did the installation of all the E1 units, all 28 of them. This shows you for 2 adjacent houses what you'd see from the ground during the construction once it was finished. What happened is we went over when they did the first property, and we threw one of these faux rocks over the lid, and you can see there a similar shot to what I just showed you. There's 2 faux rocks on them, hiding the lids for aesthetics in the community. And finally, when it was all landscaped in, you can see the 2 lids behind the landscaping here, all landscaped into the community, and one would hardly know there was anything there. And then lastly, conclusions. There was less productive space loss. Land usage was minimal. Since the unit located on the property of each resident, the widest part of the unit, 39 inches in this case, and the lid showing above ground was only about 26 inches in diameter. Improved profitability. Each of the residents in this tract, as I said, are selling from $900,000 to $1 million each. The last one I saw was listed at $1,070,000. Use of the low-pressure grind pump system benefited to the project to the tune of approximately $2 million by not having to delete 2 residences from the plan to accommodate a traditional lift station. Installation costs are lower due to the use of small diameter piping and not having to include, again, a traditional lift station and all its potential auxiliaries such as odor control systems, lifting devices, emergency power sources, storage vessels, etc. Community aesthetics are improved in not having to hide or camouflage or blend in a large lift station. And odor control. In this case, the developer wanted this to be a showcase community. He was extremely concerned about odor issues. Even we use standard vents out from underneath the lid, and typically you don't normally get an odor. But he had the vent lines run up through the building walls to the third floor deck, and then additionally, we provided him with activated carbon mushroom vents on those pipes just to make sure that no one on the roof decks would even get any whiff of any noxious odor coming from the community. So that's basically my presentation. I thank you very much for your time. I appreciate it, and we'll turn it over to Steve to continue with the presentation.
Thanks, Joe. I'm going to go back a slide for just a second here. I just want to first introduce our company. We are a engineering architectural planning firm. We are based out of St. Paul, Minnesota. We have 31 different offices and about 800 employees, primarily a Midwest company. So some of the things we look at are a little different than what Joe runs into in California and out west. We do have projects that we do in about 42 different states, and currently are doing a project that I'd like to introduce to you today in a case study in Fredericksburg, Texas. This case study is really a discussion of meeting in the middle, and that meeting in the middle is between the developer and the city. Lots of times what happens is there's issues from both sides, and what we were able to do, and I want to present to you today, is how we used low pressure systems, the terrain that existed, and the issues with the city as far as what they were willing to allow or not allow, and how we came up with an opportunity for everybody to be able to win at this situation. And so I'd like to talk about that today. The city of Fredericksburg is a small city. It's just outside the Texas Triangle of Dallas, San Antonio, and Houston. It's about 12,000 people. On the weekends, it is in the middle of wine country. A lot of people go there for vacation, for weekends. And what happens on weekends is the community becomes about 3 times the size of what it is during the week. And this is year-round. And so it's a very attractive place that people are interested in moving to. Homes in the area right now, old turn-of-the-century homes, turn of the last century that is, homes are selling for about $300 to $400 a square foot. And that's for like 1,000 to 1,100 square foot homes. So you can imagine that there's a little bit of strain on the local lot availability and the ability to meet what people are looking at as far as changing their lifestyle. There's about 25 million people within a 4-hour drive of Fredericksburg, and so what's happening is you're getting a lot of folks moving there for a change in lifestyle from the hectic life, people buying second homes there, and so the development community is trying to keep up with all that. I'd like to spend some time talking about the site next. The site itself is about 230 acres, and we'll talk about that in a little bit more detail. It sits just south of the main part of the city, but between the 2 main highways. The highway that you see on the left that we butt up against is Highway 87. That essentially is the route to San Antonio. And with Highway 290 to the right side of the screen is the direct route to Austin. So this becomes the playground for a lot of those folks. What we have is we have an existing sanitary lift station, which is the tie point that the city wanted us to utilize. And the other existing sewer is almost a mile away off to the northeast and really wasn't feasible for the site. So we focused all of our time and energy through the design process through the due diligence process and all of the communications with the city on that existing lift station. In most cities, the goal is to extend the gravity sewer as far as possible and minimize lift stations. In this city, we ran into something a little unique, and that's what the story will, as I weave through it, the story will show you how we worked through that with the city. The other thing is that sanitary lift station also, the existing one, has some capacity issues that we had to work through. So let's talk a little bit about the site itself. The name of the development is Frieden. I am not German, but the entire area of Fredericksburg, Texas has got a huge heritage of German descent. So they named it, and I can't remember, I apologize if I offend any Germans out there, German heritage, but I believe it's friendship or welcome or something like that. Anyway, something to make people feel warm and welcome about where they're going to live. We originally started off with the property that's highlighted in red on the right. There was a bit of an addition. The areas highlighted in red are residential, going to be single-family residential. The assemblage included 4 properties. 3 more additions were in the commercial areas, and those are for future phases. So I want to spend the rest of the time talking about the residential part of the project and specifically about what is so special about it and why we had to be creative as engineers. I know sometimes that word is not necessarily associated with engineers, but we can be creative if we're pushed. And so I'd like to talk a bit more about that. What you can see in the upper part of the site is you see some construction, dirt moving work, but there is a set of ponds across the north side of the site that are great amenities for the site. We spent about a year redoing these ponds to create the amenities. You can see the drone photo of the ponds as they exist today, at least 2 of them. Some of the ground shots, these are where the amenities are. And where the real highlight of the land that's going to bring the residents to the site, what they're really truly interested in as far as why they would move there. You can also see in the bottom photo, as you go from left to right, you can see the terrain rises. So that is going from north to south. We've got terrain issues like pretty much every site is. If it's a simple site and it's flat and it's easy, if it isn't developed by now, it's got other issues. It's got issues, for example, it might be a brownfield, or it might be just a stubborn landowner that just isn't ready to sell yet, or the price might be so obnoxious that people just can't afford it. So more and more we run into these difficult sites and are dealing with issues that as engineers are becoming more and more common for us than they ever used to be in the past, because quite frankly, I believe not all of it, but most of the good land is gone. Here's just some more views of why people would want to move to this site. Just beautiful property, and what we've done is taken tree surveys to maintain and work around the trees with the lots, the sites, the home sites. What was also unique is in most of the parts of the country that we work in, we work with areas that have different opportunities for house types. For example, most houses in the Midwest have basements. In Texas, they don't do basements. We also have houses that have walkouts where the basement is utilized and we use the terrain to take advantage of that drop in the back to create a walkout scenario or a daylight scenario for a half basement with windows. In Texas, that's not common. But because of the terrain and because of a lot of the discussions we had, we wanted to take advantage of that for the developer, and the developer bought into that scenario of how we can use the terrain to create more opportunity, more variety in lots, and also ultimately create some more revenue for them. As I said, the site from north to south drops off significantly. So about half of the site drains to the south and half of the site drains to the north. And if you remember, down where the E1 logo is down there is about where the lift station is that we have to tie into. So what happens is we have to, if we're going to serve this with gravity, we need to keep that gravity system deep in order to be able to supply sewer service to that northern half of the site. Just as a reminder, and this does look a bit like the property. We are tailing off towards the lakes and ponds off to the right side of the screen. But one of the things is when we don't have to rely on gravity, when we can get rid of those limitations, that's a really big deal. It opens up a lot of opportunities for us and a lot of options. The wastewater, we pump it up through small diameter pipes, as Joe said in his presentation. Lots of times they're 2 to 3 inch pipes, depending on how many houses are downstream, so to speak, or upstream, so to speak, and pressure and other issues. But typically, lots smaller pipe sizes than a gravity system. And we have the ability to eliminate lift stations. The difference in lift stations, I know Joe in his slide had lift stations could be anywhere from $250,000 to $500,000 for an installation. What we see is that's very regional and has a lot of variability to it. In this market in the Texas area, what we found is that price was going to be approximately about $200,000 for every lift station we would have to put in. And so that's obviously some significant dollars. So let's go to the plan. Very unique land plan for this property. All curvilinear design. The developer worked with the land planner to come up with a very unique opportunity that they thought would take advantage of the site amenities, create open space, a lot of green space, and also have a lot of variability with regard to not having the entire site lined up along the streets so that it doesn't look like warehousing for humans, but it has character to it and adds value. And so you see in this residential area, there's not one straight stretch or tangent street in any of it. It's all curvilinear design, which in itself causes some unique opportunities for us as engineers to try to make straight pipe follow curvy roads without adding a plethora of manholes. And so we've perfected that over time. A little bit more about the site. Again, there's 250 single-family lots approximately, or 230, excuse me, single-family lots. There's about 33 acres of multifamily. There's about 47 acres of commercial in the gray and the pink. But the really biggest thing is there's 40 acres of green space for the opportunity here. That's a really big deal for how do you get density and how do you keep your costs down and still create those amenities for the folks that are going to live there. That's what adds some challenge to us. Now, if you go back to my other slide, you'll notice that about a half or more of the residential is over the divide and off on the north side where we're a bit challenged with the topography. So what would be an engineer without a good engineering slide? Rather than looking at all the glossy things, we have to get into inverts, manholes, and a line diagram that makes us as engineers feel good about ourselves. Versus all the colors on the last side, that stuff doesn't make us feel good necessarily. This is really where engineers shine in the dull world of black and white. And I am an engineer, by the way, so I get to say that a little bit about who we are. But what I wanted to do is with this is the original plan. what I want to make sure everybody understands as I go through the next scenarios is we didn't do this in a vacuum. We didn't do this without talking to the staff, the city staff, to find out different issues. The city engineering staff was fairly new. They were in a community that they haven't worked in before, so they're a little leery of things, but we didn't necessarily get all the information that we needed to as part of the original plan. So we worked with them and came up with this plan. And again, as I said in the first slide, one of the things we always want to do is to extend gravity sewer as far as possible. That's what makes sense to us as engineers. And so we did that. We were able to get gravity systems for nearly the entire site. And most of the cities would accept this, and this would be the usual goal. And we allowed for down in the lower left-hand corner by our logo for expansion for future development to the west. And to the south, there's a fairly large brewery right off the site that has waste needs that they need to and would like to annex to. So we show the system going to there. What happened? Well, or what did it result in? And those results were this. We had some gravity sewer. That maximum depth was 32 feet. The gravity sewer minimum was 4 feet. We needed no lift stations, but in the upper corner of the site, there were some lots, 14 lots, and I'll show that on the next slide. But there was 14 lots that needed to be served by pumps. But the rest of the site and the future expansion was allowable without a lift station. We thought we'd done our job. We were very, as engineers, we were patting ourselves on the back. We had talked to the city, gone through the process with them, and so we felt good about what we were submitting as plans. 32 feet of depth, by the way, is not that big a deal in almost every location that we work in. In Texas, even in other locations, it's just not that big a deal. And you can see on this slide the low pressure lots that we were going to serve. A couple of things then started to surface. And this is, I've used this slide before, but I changed it to for just this specific city. There, finally. One of the things that city policies and standards lots of times are written as if they were brought across on tablets. People think they've been here forever. And so what happens is we get policies that are on these tablets that nobody understands why anymore. I remember my first job in 1981 out of college was with the Department of Transportation, and every time I asked a question, I asked questions a lot because I wanted to understand what we were doing and how I could do it better and do my job well. And even back then, the answer typically was because we've always done it that way. And there was no thinking of what possibly could be done better. And so a lot of this time it's based off of these types of scenarios. So the city of Fredericksburg had a pipe depth shall not be over 15 feet. And if we did have pumps, they wanted them to connect directly into the gravity manholes. And when you look at policies like this, and you look at different issues, you know, it really sends you back to almost how long ago this happened. It's based on tragedies happening, and it's based on the occurrence of pipes bursting, having to dig up streets, and all sorts of scenarios that, quite frankly, the system, it just doesn't happen that often. But that's what we were up against in this city. One of the things that I want to talk about very specifically, I always bring this up, is that too often engineers forget what our responsibility is. We might work for the city, do work for them, but in this case, we are paid by the client. We are paid to work with the city, negotiate with the city. We aren't required to bend and break on everything that the city comes up with. And our real goal is to help maximize the client's return on investment. We as engineers too often forget that this is a business venture and it's not about our engineering. There has not been a lot. I would challenge somebody to tell me that there has been a lot that they know of that was sold, that somebody bought it because they pulled into the community and they said, oh my gosh, look at how those manholes are laid out, and the hydrant locations are to die for, and oh, this stormwater system is marvelous, we need to live here. What we do is different than that. What we do is an expectation of those folks, we need to keep that understood. So we went back to the table, and the city said, we don't like low pressure. We want a 15-foot maximum. And so what we did is we redid the whole design. So that maximum of 15-foot depth. We had ended up with 4 lift stations. And at those 4 lift stations added about $800,000 worth of cost. And no lots were served by a low pressure system. Quite frankly, no one liked that option. But we wanted to show the city what the 15-foot maximum depth meant. So that got us at the table to talk and negotiate and come up with a better plan. So then what happened was something very interesting. The Public Works Director was sitting in the meeting with us, and the voice of reason suddenly came out. And he said, and this is about as much as I can quote, I might be a little off, well, we don't encourage, don't discourage the use of low pressure systems. We immediately saw a chink in the armor and a softening and an ability to work with these people. So this again is a story about working with the city, listening, understanding what their needs, worries, and concerns were, understanding the profit requirements and the return on the investment of our client, and bringing those together. I'm going to skip this next slide because Joe showed the same slide, and so I'm just going to skip that one for right now. So what we did is we went back to the drawing board. And that drawing board, what it did is it changed the scenario of how many lots we could put on low pressure. Now, did we go back to the system and go to the 15-foot requirement? The answer is no. That 15-foot that I showed, their maximum requirement, we actually negotiated with them, and we have some pipe that's up to about 20 feet, but in very short sections, and they were okay with that. Number of lots stayed the same. That's the most important thing. There's no lift stations. And we went from 14 to 42 lots served by not just pumps, but by low pressure sewer. And the city approved it. That is the biggest thing, is at the bottom, is that the city approved it. The other thing that we forget to talk about a little bit too is the tail of the tape, but also the cost transfer. Most builders, or most developers, when a pump is going in, it goes from a developer cost to a builder cost. And so it actually helps them out significantly in their return on their investment on their lot prices. Those are things that we also need to consider. So when you look at the original plan, just the sewer system, what we looked at is $614,000. The city policy, if we would have had to do that, it would have cost an additional $689,000. The low pressure plan, the last one that we got approved, actually went down, and we had a total savings to the developer of $185,000. And not just that, but the city won as well. Everybody is happy with this plan. It's moving forward. Final plat is about set to go in, and it took a long time, but for a lot of reasons, the right thing happened, and the ability to serve and utilize and talk with the city and pull them into thinking differently rather than pushing them was a really big deal. With that, I'm going to turn it back over to Mike to handle any questions that people have. I appreciate your time, and Mike, it's all yours.
Gentlemen, thank you very much. Our first question, what is the cost per lot for the installation of the station?
That's going to vary, you know, in what part of the country you're in. You know, generally, and it's going to vary on what size system you put in there. We have different models, but I'd say, for example, a basic, very basic E1 pump might be in the neighborhood of $5,000 to $6,000 for the station, and the installation is probably, in most cases and generally, about a similar amount of dollars. I could tell you the one we did in Costa Mesa, we did the installations for about $3,500 to $4,000 per lot.
Our next question is from Mary. She's asking, how does this system vary from the vacuum system? She's in Inglewood, Florida. I don't know if you're familiar with that area, but she's asking what's the difference between this one and the vacuum system?
I know, Steve, can you answer that, or?
I was hoping that if George is available, he could answer it. I have not, our company has not done vacuum systems, so Mary, I can't answer that question, but I'd certainly be happy to get back to you on that. Joe, I know you being on the other side of things might have some more information, but ultimately E1 is the folks that could really help you with that.
Yeah, all I could say on it is I know it's a much more complicated system. You have to have vacuum stations periodically. The piping tends to go in a step to each station, and there's quite a bit of maintenance that's required on stations. So I don't know if George might have something more to add to it.
Okay. Our next question, what is the average cost per foot to install small diameter sanitary sewer force main in bedrock using directional drilling?
I wish I had one of my coworkers on the phone with me right now. I think he's actually listening in. We just did a sewering of a large lake in northern Minnesota, where I believe it was 80+% of the pipe had to be bored in. Small diameter pipe. All it was done was with E1 pump systems, so we did a low pressure system. And I can certainly get back to and answer that later. With regard to that, we have the number. I was not involved necessarily in the final engineering of that, so but I can certainly get a number for that.
I can add.
It wasn't cheap.
Yeah, I can add something to that. When you're talking about bedrock, that's a little more difficult. I'm not even sure they can directionally bore through bedrock. Typically, though, in normal soil, considering your different size pipes are going to have a different cost. For a 1 1/4 inch, let's say, and the length of line, depending on if you're going to be putting in 5,000 feet of pipe, you're going to get a different number than if you're putting in 500 feet of pipe. But I would say, in general rules, when we price them up for budgetary purposes, we use about, for a 1 1/4 inch line, we use between $17 to $20 per foot installed cost.
Okay, very good. Winter is upon us, so we've got a vacation home question. How do you design for vacation homes around a lake? In the winter, owners are gone, and the entire system flows are very low. In the summer, the flows are higher and very high in the holidays. So who wants to take that one?
Joe, in California, I bet you don't have this question come up very often. I suppose I better take it since I'm a Midwestern guy.
Go right ahead.
I actually I have the privilege of owning a lake home in northern Wisconsin. I'm there maybe a week or two a year in the wintertime. What happens is there's this little thing in freezing conditions called snow that helps insulate the ground typically. If you get a low snow year, the other thing that happens is frost can penetrate. We've done jobs in Alaska where we had to put pipe 14 feet in the ground to keep it below the frost line. In a lot of Midwestern states, you're looking at a 6 to 8 foot bury depth on pipe to keep the frost from penetrating that far. So really what it is you don't want the system to freeze up. And so you put the pipes in deep enough, or you can insulate over the top with styrofoam insulation, high density foam, that essentially makes the frost go down and around the insulation to protect the pipe.
I can add that I'm aware of a project a different distributor worked on for you in Alaska, and very severe frost conditions, and they actually built little buildings around it that were heated around the unit. So that was another solution, little doghouse type.
You can also insulate the cover, like Joe showed the faux rocks going over the top. You can do things like that out of insulation. You can also put a insulation collar around the outside of styrofoam that again makes that frost to not just go straight down but go down and around. So those are all sorts of options that we have as standard details that we use for all sorts of installations.
Okay, another question from our audience. I'm going to try to put this together as best I can. The low pressure pump system at the last connection point, is the low pressure pump system at the last connection point getting bigger? What is the range of horsepower for these systems?
So all the E1 pumps are progressive cavity. They're typically 1 horsepower, or all 1 horsepower, and they're typically 240 volt single phase pumps. And so it's the same one, and we can pump. We can generate 185 feet of head out of that. So depending on your elevation change, we can go straight up in the air 185 feet, or go for a couple of miles straight on. And there's a thing called simultaneous operation of pumps. When you have this type of system, the probability that all pumps will come on at once is nil. Matter of fact, in Costa Mesa, for the sanitary engineer, he said, well, what if all 28 pumps did come on at once? And so I did a probability calculation for him, and it came out that it was 0.39 zeros before I hit a number was the probability. So these pumps come on for 1 to 3 minutes at a time and shut off. And if you have a system, say, with 30 pumps on it, you may only have 3 or 4 operate simultaneously.
And again, Joe, you might want to reiterate too. This is a low pressure system, not a high pressure system, which is what we mostly talk about with regard to lift stations. And the low pressure system helps to also relieve some of those issues.
Yep.
Okay, we have a question about a land development scenario. We are looking at a 7-lot subdivision and need to pump the sewer up the hill to the existing sewer. Can we do individual low-pressure systems with individual grinder pumps into a junction box or manhole, and then gravity into the city system?
Yes, that's pretty common. That happens all the time. The system for the 28 units in Costa Mesa, that's exactly what it does. Every house has an individual unit. It pumps to an area where it finally dumps into a gravity manhole altogether, and the size of the pipe for all 28 units is 3 inches.
Same thing with the case study we did in Texas. All all of those houses that were shown at the end of the line are all pumping into a low pressure and then a direct dump into a gravity manhole.
Okay, well, Joe, Steve, I think that wraps it up for our questions and this webinar. Any questions we did not get to, we will answer offline. On behalf of Professional Builder and our sponsor, E1 Sewer Systems, I would like to thank everyone for their participation. And just a reminder, this webinar will soon be archived at the same URL that you used today on probuilder.com. Thanks for joining us, and so long, everybody.